This tutorial will show you how to import and use the ISET optic structure to run a simulation. Computational time to run a ray trace simulation depends on the size of the scene and the number of wavelength bands in the scene data. We recommend that you first test the simulations using a relatively small scene image with a few wavelength bands. In our example, we will select the ISO 12233 slanted bar target from the scene menu. Then we will reduce the size of the scene and the number of the wavelength samples. You can reduce the size of the scene by changing the parameters in the box under Adjust Scene. You can reduce the number of wavelength samples by selecting the Edit pull-down menu. Select Adjust SPD and then Resample Wavelength. A box will appear that will let you change the start, stop, and spacing of the wavelength samples. Now that we have a scene, we can open the Optics window. Select Import Optics from the Optics menu. Locate and open the file containing the ISET optic structure. Now you can select Compute Optical Image in the Optics window. A window will appear to show you the progress in computing the point spread function at different locations in the optical image. As I said, the computational time to run a ray trace simulation depends on the size of the scene and the number of wavelength bands in the scene data. And even though we chose a very small scene with relatively few wavelength bands, it still will take a considerable amount of time. So we're going to speed this up and show you this, not in real time, but it will show you the entire process. The image that you're seeing illustrates the point spread functions at different locations in one wavelength band. Now imagine that there are many wavelength bands in a radiance image. So this is what it's going to take. Now we're seeing the PSF calculations for another wavelength band. Of course, computational time depends also on how much RAM you have in your computer. If you can add more memory, you will be decreasing the computational time. Don't worry, we're not going to make you watch this entire process. We'll speed up the video so that you can see the entire process, but it will not be shown in real time. Now you can see the results for a third wavelength band. Now you have the optical radiance image generated using ray trace calculations and the ZEMAX lens design.